Today we are going to be looking at box and whisker plots. So, what are you going to learn? You're going to learn what a box and whisker plot is, how to interpret one, and then how to create one. So a box and whisker plot is used to summarize and analyze data. It graphically displays the median, the quartiles, the interquartile range, and the extreme values in a data set. And it can be drawn vertically or horizontally, although we typically see them vertically. So this is a box and whisker plot. I call it a box and whisker because we got a box and we got a whisker. So these little dots are all important parts. This is my maximum, okay, or sometimes we call that the upper extreme. This is my minimum, or the smallest set of piece of data in my data set, and we call that the lower extreme as well. So you could see it either way. This point right here is what we call the lower quartile. And when you look at the next slide, I think that will help you understand that a little bit better. And this is the upper quartile. Okay, sometimes we see this as quartile 1 and this as quartile 3. And then this point is the median. And what the box and whisker plot does is it forces your data to be in 4 equal sets, meaning if there are 20 pieces of data, there would be 5 pieces of data here, 5 pieces of data in the box, 5 in here, and 5 in here. Okay. Notice, though, when we look at a set of data, you usually think about the mean, right? And the mode. Well, you can't see the mean because it doesn't give us single data points, and we don't know how many data points are in this set unless we give it to you. So when we distribute data, 25% of my data falls along this whisker, 25% falls in this box, 25% falls in this box, and 25% falls in that box, or 1/4, 1/4, 1/4, and 1/4. So remember I said that this point here was a quartile, this was the upper quartile, quarters, it marks it into 4 points. So basically, let's say I had 200 pieces of data. Okay. I'm going to divide that by 4, and that means that I've got 50 pieces of data here, 50 pieces of data here, 50 here, and 50 here. Now, the box and whisker plot is going to be spread out or smushed together depending on how close those values are. So here I have a box and whisker plot, and it is on this graph, and I want to find the following. Well, right away, I told you that we can't find the mean, so we're going to say not applicable. We can't find it, and we can't find the mode either. Okay. What we can find is the median, and that's always going to be this bar in the box and whisker plot, so it's going to be 13. Okay. The range is going to go from your minimum, which is 2, to your maximum, which we're going to say is 22. So your range is going to be 22 minus 20, 22 minus 2, which is 20. My upper quartile is this point right here, and we're going to say that that is 15.5. We're going to use our estimate because in the real world data isn't always so neat. And my lower quartile is right here, or 6. Now my interquartile range is my upper quartile minus my lower quartile. So that's this right here. So 15.5 minus 6 is 9.5. So that's my interquartile range. So my interquartile range is what's in this box right here. It's the middle part of the data. Now, this question says, if 120 people were surveyed, how many said between these things? Now remember, I said that the Box and Whisker puts it into 4 equal parts. So we're told we have 120 pieces of data, so 120 divided by 4 gives me 30. So there are 30 different pieces of data here, 30 here, 30 here, and 30 here. So between 6 and 15 and a half, there's 60 pieces of data. Okay, 13 is the median, it's the middle. Half of the data is above that, so 30 and 30 is 60. Below 6, so we're going to go below, so from here down, there are 30 pieces of data. More than 15, so from here up is 30 pieces of data. Below 13, which is the median, is going to be 30 and 30, or 60%, 60 pieces of data. In between 2 and 13 is half again, so that's 60% of the data. So it just forces this data into 4 equal quarters. Now, if you're going to create your own Box and Whisker plot, you need a number line, otherwise it doesn't mean anything. You need the smallest number, the minimum. You need the maximum, the largest number, a median. And if you recall from 6th and 7th grade, when we put the numbers in order, it's the number in the middle. When there's a lower quartile, it's going to be the median of the lower half and the median of the upper half. So let's look at finding medians real quickly. If I have an even set of numbers, so I've got an even set of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 pieces of data, it's going to be the exact middle. So I've got 10 divided by 5, so there's going to be 5 on each. I think some of your teachers probably taught you to check off. So I checked off 2 on the ends, 3, 4, 4. And when I check these off, my median is going to be right here in between them. So what you do is you find the middle of that. And hopefully common sense tells you that it's 15 and a half. So our median is 15 and a half. If you can't remember, it's just the average. 15 plus 16 divided by 2 is 31 divided by 2. So that is our median. Odd numbers are a little easier. You don't really, all you have to really do is count. So if I have an odd set of numbers, this time I've got 9 numbers. So this had 10, this one has 9. Okay, so if I check off the ends, there's 1 on each end, and another 1 on each end, here, here, and here. So that leaves an exact middle number, which is 115. So that's how we find a median. Okay. Now let's create our own Box and Whisker plot. And I've found the medians and the quartiles here, but I'm going to walk you through it. So here's our set of data. There were 9 points, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 114 is my middle number. So that's my median, 115. My lower quartile is the median of the lower part of data. Okay, so I'm going to just look at these 4 numbers here, and it's the median. So since it's 4, it falls right in between here and here, so it's 11 and a half. The upper quartile is the median of the upper half. Okay, so that's going to fall right here between 120 and 130. So that's not so necessarily, it's not one number between them, so we can do 120 plus 130 divided by 2. So you're going to get 250 divided by 2, or 125. Okay, so I need those to make my data, and I also need my minimum, which is 111, and my maximum, which is 131. So we kind of want to graph and do a number line so we can interpret this. So I'm going to draw my number line in, and between 131 and 111 is 20 points. So I'm fairly confident we can go by ones on this. So I'm going to label it 110, 112, 114, 116, 17, 118, 120, 122, 23, 124, 126, 128 here, 130, and 132. So I just skipped so it's not all smushed together. You could even go by threes if you wanted to. So I'm going to start by graphing my minimum of 111. I'm going to put it right there. My maximum of 131 is going to go here. Okay. And then just in order, my lower quartile is 111 and a half. So it is really close here. Okay. I'm going to draw a line between them. My upper quartile is 125, which is here, and that's where my whisker is. I'm going to draw a box from my quartile, upper quartile to my lower quartile, so actually from here to here. And then my median that goes in the middle is 115. Okay, now notice that with this data, we've got everything scrunched really close in here. So even though there's 50% of the data from here down and from here up, it looks like there would be more data above the median. But remember, it's the middle number. And if you look at our data, I don't know where it went. So if we look at our data, notice that from here to here, there's only a range of 4. But from here to here, the range is 16. So the data is more spread out. Okay, so we've got data clustered really close together here. And from here on, it's really spaced out. So that's one of the nice things that a box and whisker plot can show you. And we're going to be looking at measures of spread in the next lesson. Okay. So let's just compare two. And this is the really strength of this. I can take two different things and compare them. So you guys do science fair, and I know some people have done effects of sleep, effects of caffeine, different things in the science fair, because I've seen them and I've judged them. So this set looks at a study of the effects of caffeine on memory recall. Okay, so we're asked to take a memory test 2 hours, either drinking a caffeinated beverage or a non-caffeinated beverage. And we had 85 volunteers who drank the caffeine and 80 who drank the non-caffeine. And so the results of the number items recalled are in this box and whisker plot below. Okay, so this is my caffeinated people. This is my non-caffeinated people. So notice that one of the things I would notice is that my minimum for my caffeine, the minimum recalled words, was lower, as was my maximum. So everything is lower on the caffeine. So that would seem to just tell us that memories aren't real good on caffeinated people. Okay, my medians are higher, and everything is higher with my non-caffeine. In fact, my median is the same between my caffeine and my non-caffeine. Okay. And here, it looks like my upper quartile is 24. So let's actually write that in. So my upper quartile is 24, or my maximum is 24. My upper quartile is 22. Median is 20. Lower quartile is 19, and then 15. And then we can see in the caffeinated, our minimum is 12. Our lower quartile is 16. Our median is 19. 21 for our upper quartile, and 22 for the maximum. So if we look at the range, 22 minus 12 for the caffeine is 10, And for the non-caffeine, I'll abbreviate, the range is 9. Okay, so it's a little bit, the range is higher in the caffeinated than the non-caffeinated, but we can see plainly that the people who drank the non-caffeinated beverage had a better recall. So kind of to summarize, the non-caffeine is more clustered than the caffeine. The median in both quartiles are higher in the non-caffeine. And then it's 40 people were in the inner quartile range in the non-caffeine. So in the non-caffeine, remember, it breaks everything into 4. So if you have caffeinated or non-caffeine, if you take 80 and break it up into fourths, you're going to get 20 here, 20 here, 20 here, and 20 here. Okay. Because 85 volunteers drank the caffeine, it's a little harder to break it up. But probably you're going to have 21 piece of data is going to sit here, 21 and 21. So you're going to have your median being an actual piece of data. So to recap, Box and Whiskers are great for comparing two, I can't spell, don't tell Stroman, 2 different data sets. And it's a great visual to see the spread, but we can't see the mode or the mean. Okay. So have, as my buddy Chris says, a math-tastic day.